Okay, so now for the topic I've been building up towards cancer. This is probably a topic of a lot of interest to a lot of people. It's something almost everyone knows about, and an unfortunate number of people have some sort of personal experience with. So the first question is, what is cancer? And so cancer is a malignant neoplasia. So let's start off with neoplasia. Neo means new, and plasia means growth, technically, but in this context it means cells or tissue. So neoplasia specifically refers to the growth of tissue through cell division and mitosis. So a neoplasia is just new cells. In a medical context, we talk about neoplasia as an abnormal growth. When you have new cells in a place that should not have new cells. This abnormal growth is growth that is disconnected and uncoordinated with nearby tissue due to the reasons, or at least due to, among other reasons, for the reasons that I talked about in the last video. When all of the cells of a neoplasm is a group of new cells. When all of the cells of a neoplasm are gathered together in a mass, it's called a tumor. Most neoplasms are tumorous neoplasms, but you can have neoplasms that result from say, like blood cells or something like that. Where the cells end up being spread out throughout the body as opposed to all gathered in a tumorous mass. Here you can see the very beginning parts of a neoplasia. These cells are all growing together in a mass. This is a very small one. Here you can see these cells here are growing out in a mass from this tissue. So neoplasms can be either benign or malignant. A benign neoplasm, or what's called a benign tumor, these grow, but they remain in the same place, in the same local area. Often they are encapsulated with some sort of membrane surrounding them that keeps them from spreading out. So that's called encapsulation. And these may be characterized as benign tumors or sometimes cysts or whatever. But they have a very definite boundary that separates them from the surrounding tissue. One example of a benign neoplasm is a nevus or a mole. And moles are fairly benign, at least as long as they stay moles. I should point out that just because a tumor is described as being benign doesn't mean it's harmless. It just means it's not malignant cancer. Benign tumors can sometimes produce hormones, which can result in a number of hormonal disorders. They can also, as they grow, put pressure on surrounding tissue, which can cause that tissue to lose function or to deprive it of oxygen or something like that. Benign tumors in the brain can have severe effects on people's cognition, even if they don't ever become cancerous. Those ones are also particularly difficult to operate on. However, because they are encapsulated, if a benign tumor does become a significant problem, usually they're pretty easy to take out, unless they're like buried in the middle of the brain. Then they're harder to take out. If a tumor is not benign, it is malignant. Malignant neoplasms are called cancers, and they spread and invade normal tissue, setting up colonies at distant locations. There are a few different ways that they can do that. One is you might have like a mass of cells that sends out like tendrils in a location. It then founds another mass of cells, and that can send out tendrils somewhere else, and they can grow in chains like that. But more common and more dangerous is when you get cells that detach from the central cell mass and found new cancers in far different tissues. Often they migrate into the lymphatic system and then through your lymph ducts and lymph nodes in order to get all over your body. So this ability is called metastasis or metastasis, either or. And so an example of a malignant neoplasm would be melanoma, which is a skin cancer variety of the melanocytes. So, what causes cancer? First off, cancer is a genetic disease. But that doesn't necessarily mean that it's inheritable. Very few cancers are like inherited in the sense that you're born with them, because if you're born with a cancer, you usually probably died long before you were born. There are some forms of cancer where like a higher risk of getting them is heritable. You may have heard this in the context of, say, the BRCA1, BRCA2 breast cancer genes, but there are many others as well. However, most cancers do not have a strict inheritance link, but yet all cancers are genetic in nature. And that is because cancer is fundamentally a disease caused by mutations. Even if you inherit like a higher likelihood of getting cancer, you're still going to need several mutations in different genes before that cancer can actually, well, become a cancer. Since mutations, plural, are what causes cancer, anything that causes more mutations increases the likelihood of cancer. So, you may have heard of things described as being carcinogens, and other things as being described as mutagens. In general, anything that causes mutations is going to increase the likelihood of cancer. And anything that increases the likelihood of cancer fundamentally results in your body accumulating more mutations. So if mutations cause cancer, then what causes mutations? And mutations fall into two categories. They can either be spontaneous or induced. Most of you probably think of induced mutations when you think of mutations, right? These are going to be mutations that are caused by a thing, usually a thing external to the body. This could be X-rays, or it could be an infection like viruses, or it could be toxic chemicals in the environment or whatever. This is going to be a thing that causes an increase in mutations in your body. Some of these induced mutations can be caused by chemicals made in your own body. Yeah, like most of them are going to come from outside. So anything that induces mutations is called a mutagen and will also probably be a carcinogen. The more you are exposed to a mutagen, the more mutations you will get. And that will almost always increase the likelihood of your getting cancer. I mean, unless it kills you. Because if it kills you, you probably don't get cancer after that point, since you're dead. The other category is spontaneous mutations. And spontaneous mutations aren't caused by anything. That's what makes them spontaneous. And every time, your cells divide, and your cells do a lot of dividing, every time they divide, mistakes can be made because biology is sloppy, right? Biology is imperfect. Enzymes screw things up. So, they might make a mistake for 1 out of every million bases that they put down, right? And that sounds like not a whole lot. Like there's, it's 1 out of a million. It's not a bunch. But when you consider that in each of your cells, you have something like 10 trillion base pairs. That means that every time your cells replicate, you could get 1 million mutations. You don't. At least not quite that much. But you could get a whole lot of mutations. Just simply because you've got a bunch of DNA. And so even a very, very low mutation rate is going to result eventually in those mutations adding up. Spontaneous mutations happen at a pretty much constant rate. They always happen whenever your cells are dividing in the background, and there isn't really anything you can do about it. They're just always going to be happening every time your cells divide. So to a certain extent, even if you get rid of all of the induced mutagens, you never expose yourself to any toxic chemicals or radiation or anything like that, that won't stop cancer because most mutations, and it is most mutations, are just random. They just happen. Of these, spontaneous mutations are much more common than induced mutations. But, in general, the number of spontaneous mutations that you get is fairly constant. Whereas the number of induced mutations that you get can vary widely. It could be practically nothing for a long time, and then you get exposed to some toxins, and it jumps up and spikes really high, and then comes back down. So, induced mutations are usually going to come whenever you get into contact with whatever it is that's causing the mutations, whereas spontaneous mutations happen at a relatively constant rate just in the background. So, What causes cancer then? What about mutations? How do mutations cause cancer? So mutations don't just happen in cells. Mutations happen in cells. If every mutation that happened in a cell persisted, you'd be dead. In fact, you probably would never have been alive in the first place. You never would have been born. Because, like I said, even that spontaneous mutation rate can result in millions of mutations every time a cell divides. Well, we just can't leave it at that. So your body and your cells have repair enzymes. You have a natural mutation rate, but you also have a whole bunch of things that as soon as the DNA is copied, go in and look for errors and try to fix those errors when they find them. It's kind of like, all right, like imagine you're typing a paper, like for a class or something like that, and you don't have spell check, you don't have any autocorrect, nothing like that. You just start clackety, 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 going through and you're doing the whole thing, right? Well, you're probably not going to spell everything right. There's going to be a whole lot of errors. And before you turn that thing in, you better go check it out and make sure that you have spelled all the stuff right. And even if you go through and reread it like a whole bunch of times and maybe have somebody else reread it a bunch of times, there's probably a few spelling errors that you're going to get through. But you'll probably catch most of them. So the mutation rate is the rate at which new mutations happen minus the rate at which they are repaired. So maybe you get 1,000 mutations per cell cycle, and you are repairing 900 of them. So then the mutation rate would be 100 new mutations per cell cycle. And there's generally three things that increase the rate of mutation. And anything that increases the rate of mutation is likely to increase the rate of cancer. Number one, anything that causes mutations, right? Right? If you cause more mutations, then more mutations are going to get through. This would be something that, for instance, a mutagen, right? If you're causing mutations, you pretty much got to be a mutagen by definition. So, right? Imagine that you're writing your paper, except now you're drunk when you're doing it. You're going to make more mutations. You're going to make more spelling errors, right? There's a thing, it causes more errors. That's going to increase the mutation rate. But that's not the only thing that increases the mutation rate, because you could also have something that prevents you from effectively correcting them. So that's number two here. Anything that interferes with the repair mechanisms or removes the ability of a cell to destroy itself if they're unfixed, right? If cells get very serious, severe mutations in them, they'll often undergo apoptosis or cell suicide in order to kill themselves off before they become cancerous. So if anything stops a cell from being able to repair itself or kill itself if the damage is too extreme, means that more mutations are going to go through. So in our example of like writing a paper, this would be normally when you're writing a paper and you misspell something, the little red squiggly appears underneath it. Right. So what if the little red squiggly no longer appears underneath it? Well, when you're going back and you're correcting stuff, you're going to have a lot harder time finding them, and you're going to correct fewer errors. That means that there's going to be more errors in the paper that you finally submit. And 3, anything that causes the cells to divide faster. So cells only have as much time to correct errors as until the next time they divide. All right? Once a cell divides, any mutations that are still there are stuck. So that G2 time point, right, that's the time that you have to fix the errors. What if that becomes shorter? Now you have less time to fix the errors. Having less time to fix the errors means you fix less errors. So, like, what if instead of having a week to go through and proofread your paper, you now have an hour? Are you going to get everything fixed? Probably not. Less time means you're going to do a less thorough job. So, for instance, like X-rays, right? X-rays are a mutagen. They're going to cause an increase in the number of mutations. That'll increase the mutation rate. That's a carcinogen. Nicotine interferes with repair mechanisms. So nicotine, of course, found in cigarettes. It binds to repair enzymes and inactivates them. So you do not fix as many mutations. That means if you're making the same mutations and you're fixing few of them, more mutations are going to get through. The mutation rate goes up. The cancer rate goes up. But also anything that causes cells to divide faster. So, for instance, asbestos works through this mechanism. Asbestos does not cause mutations. It does not stop you from repairing mutations. What it is these little spikes of material that get in your lungs and they kill cells. Well, if you constantly are having cell damage done to your lungs, then that means your cells have to reproduce much faster in order to repair the damage. You're increasing the rate at which cells divide. That means they have less time to fix their errors, and more errors are going to get through. Any of these 3 things will increase the mutation rate and thus increase the cancer rate. Not all mutations are created equal. Most mutations just don't do anything at all. Most of your DNA is what's called junk DNA. It doesn't code for anything in particular. And if a mutation happens there, it's probably not very important. Most mutations that happen in actual genes and important bits of the cell probably happen in an important bit of the cell, and then the cell dies. So most mutations are going to just do nothing, and if they do something, they're probably just going to kill the cell. But of those that don't kill the cell, a very small number of them can cause the cell to exhibit new behaviors. And those new behaviors can include losing control of their replication. There is no one mutation that will cause a cell to become cancerous. If there was, we'd all have died of cancer long ago. It usually takes several different mutations in the same cell all happening together in order to cause cancer, which is why, thank God, cancer is relatively rare. Generally speaking, these are the processes that have to be mutated in order for a cancer to happen. So, first off, you have to have something that is going to bypass the cell checks. The G1 checkpoint and the G2 checkpoint. As without the ability to just bypass and blow through those, the cell won't be growing out of control. It'll still be controlled. These genes are called oncogenes. And so mutating an oncogene can cause the cell to want to replicate endlessly. There are also things called, so you have to have at least one oncogene mutation. I even put that in here. At least one. Second, you have a whole bunch of genes that are called tumor suppressor genes. These are things that detect when a cell has become tumorous and respond usually by causing the cell to kill itself, to undergo apoptosis. So these tumor suppressor genes, they detect when a cell is becoming tumorous and they off the cell. You need to have mutations in all or most of the tumor suppressor genes. Well, that's not quite true. A lot of them happen in a pathway. So you might have like A leads to B, leads to C, and you might have D also leads to B, which leads to C. And you wouldn't necessarily need to cut all of them off. You would just need to cut off B or C, because that would block the path. But there's a number of different tumor suppressor pathways, and you have to block all of the tumor suppressant, all or most of the tumor suppressor pathways with mutations. Otherwise, your cancer is going to kill itself off before it even really gets rolling. You need a mutation that is going to allow it to ignore density-dependent inhibition. As we talked about in the last video, when cells become too crowded, they just stop growing because they don't have anywhere to grow to. Obviously, if you just stop growing, you're not a cancer. So something has to be mutated to turn off the density-dependent inhibition pathway. Okay, at this point, if you get up to 3, you can start growing as a tumor. But you're not going to get that big as a tumor. Because as this mass of cells grows, well, your cells require oxygen. And tumor cells, since they're growing very fast, usually require quite a lot of oxygen. This mass of cells doesn't have any blood bringing oxygen to it. So it can only get so big. It can only get big enough that oxygen can reach most of the tumor. So it will naturally have a limit on its growth due to lack of oxygen. So we're going to need another mutation. This mutation has to allow the cancer, or the tumor, to send out a chemical signal that will cause the body to build new capillaries inside of it. This process is called angiogenesis. Angio means blood vessel, genesis means to begin. So, angiogenesis, or a mutation that allows the cell to do angiogenesis, will allow it to basically build capillaries inside of itself so that it can get oxygen to all of the parts of the tumor that need to get oxygen. All right. With angiogenesis, the tumor can now grow quite large, but it's still a tumor, not technically a cancer. In order to become cancerous, it needs to have a mutation that allows it to ignore attachment dependence. And this is what we talked about in the last video, where most cells have to remain attached to other cells and to what's called the extracellular matrix of whatever their native organ is. and so they can't really spread. In order for it to be a cancer, it has to be able to spread. It has to be malignant. So with most cells, if they let go of other cells and they become separated from the pack, they can no longer reproduce. That's what attachment dependence is. And we need to have a mutation that will destroy that dependence, so that the cell is now allowed to multiply even if it's not attached to anything. Okay, so at this point, up to 5, now you've got a cancer. And your body generates cancers on a pretty regular basis. All bodies generate cancer on a pretty regular basis. Most of these cancers are smashed in infancy by the immune system. Your immune system has special components that go around looking for weird cancer cells, and when they find them, they kill them. So in order to really become a cancer that you will notice and which might kill you, the cancer is usually going to need either to be very, very lucky or to have some sort of mutation that allows it to avoid the immune system. Probably not completely avoid it, but that makes it somewhat resistant to the immune system. In general, at least if we're talking about hard cancers, leukemias and blood cell cancers, different issue. But for most cancers, unless you do all of these steps, then it probably won't ever get large enough to become noticeable and cause you problems. At least not cancer problems. All right, so we talked about what causes cancer. Mutations cause cancer. And what causes mutations? Well, these are the 3 processes that can result in increase in mutation. All right, that's all well and good. What should I not do? What can I do about my life in order to not get cancer? Well, the things that cause cancer break down into what are called endogenous and environmental factors. There's nothing you can do about endogenous factors. These are things that are inherent to your body. There may be things you can do about environmental factors. That's where I would recommend that you focus your efforts. So endogenous factors are usually going to be things that you're born with, or things that are at least inherent to your body that you can't change. So your genetics is an endogenous factor. Mutations that you've accumulated, you've got them, they're there. Oncogenes, tumor suppressor genes, DNA repair genes, right? All of those sorts of things. What genetic factors you've inherited from your parents? You may have inherited from mom or dad, or potentially both, a tumor suppressor gene that's already broken. Maybe their tumor suppressor gene got broken and they passed that broken gene on to you. Well, you now have one less gene that needs to be broken. This is usually what happens when you inherit a increased likelihood or a propensity for cancer. It means that a few of your genes, usually tumor suppressor genes, are pre-broken. And so it's going to be easier for cancers to start. Sex matters. So does race, although we don't know why race matters. We don't know if it's biological, or if it's sociological, or if it's both. But definitely certain cancers are more common in some races than others. Hormones. Yes, hormones control a lot about how your body uses cells. And so If you have more or less or different types of hormones, that can be an endogenous factor, and your immune system, right? Different people have different strengths to their immune system. Some people's immune systems, well, you can't really call it as being stronger or weaker, but some people's immune systems are just better at some things than others. And your immune system may be really good at dealing with cancers, or it may be really bad at dealing with cancers. Or it may be more complicated than that. It's usually more complicated than that. But you get the picture. All right, the environmental factors. Tobacco, obviously. Everyone knows this. Industrial chemicals, huge number of them are potential mutagens. Diet, important because it affects your immunity. Your diet also affects like lots of things. Stress due to high glucose levels and diabetes can cause damage to tissues, which can result in a higher rate of mutation. Alcohol, well known to cause certain types of cancer. Chronic infections, certain things like, say, HPV, potentially herpes virus, Epstein-Barr virus, and other infections can lead to a higher incidence of cancer because they get in your cells and alter your genes. Certain medicines can result in a higher incidence of cancer, either because they might directly cause mutations, but more likely they interfere with somehow your abilities or your body's ability to repair mutations or your immune system's ability to find cancer. Ionizing and ultraviolet radiation. Ionizing is like X-rays, and UV is UV. Those are both things that are found in the environment that cause mutations. This is not an exhaustive list. There are lots of things that can cause cancer that are not on here. So like this is just a partial list. Cancers are usually classified according to the type of cell and type of tissue they come out of, and whether they're benign or malignant. I should say tumors are classified. So a carcinoma is epithelial cells. A sarcoma is connective tissue. And mixed cancer is both. Muscular and nervous tissue very seldomly generate cancers. Lymphoma is a cancer of the lymphoid tissue. Leukemia is a cancer of the white blood cells. Melanoma is a cancer of melanocytes, which are skin cells that produce melanin pigment. Generally speaking, if something just has oma after it, it is probably benign. Maybe benign. If something has sarcoma after it, if something ends in carcinoma or sarcoma, then it's probably malignant. So adenoma is a benign tumor of the epithelial cells, whereas adenosarcoma is a malignant cancer of those same cells. A papilloma is a benign is basically it's a wart. A wart is a benign tumor of the skin cells, whereas papillary adenocarcinoma is a cancer of those same skin cells. Lipoma is a benign tumor of fat cells, whereas liposarcoma would be a malignant cancer of the fat cells. So generally speaking, that's what's going on there. Whenever you hear cancers or tumors described, now you'll have some sort of basis for it. But generally speaking, anything that ends in oma is probably going to be some type of tumor. When we stage cancers, by which I mean like when we describe the progression of cancers, we describe them T for tumor. So this is the primary mass, the largest mass. N stands for lymph node, N for node involvement. M stands for distant metastasis, M for metastasis. So T0, no tumor. T1 through 4, there's a tumor. Bigger the number, larger the tumor. TIS, it means in situ. That means it is like just barely starting to form. N for nodes. N0 means that there's no evidence of it migrating to the lymph nodes. N1 through 3 means there is evidence of it migrating to the lymph nodes. And like larger numbers are worse. They mean it's either spread further or it's spread to more lymph nodes. And usually, since cancer spreads through the lymph system, the lymph nodes are the first thing affected. M is metastasis. Again, 0 means no metastasis. M1 means you have distant metastasis, that cancer has spread through the lymphatic system, popped out the other side, and has lodged itself in some distant organ. And cancer is usually rated by like stage 1, 2, 3, and 4, depending with, increasing severity to each one. So stage 1 cancer would mean that you have a few metastatic nodules, but they're neither very big nor very far away. Whereas stage 4 cancer means multiple metastatic nodules in multiple places throughout the body, that some of them themselves are then founding their own colonies. That's very late stage cancer. As far as diagnosis of cancer, there are a few different ways, depending upon the type of cancer. So you can look for lumps, if we're talking about breast cancer, testicular cancer. There's other things that you can screen as well. You can, sometimes you can see incipient melanomas. Sometimes you can see or feel, a lump in some other weird place. There are also tumor markers. These are proteins which are detectable in the blood that they don't cause cancer, and cancer may even not cause them, But these chemicals are known to be at high levels when cancer is present. So there are some blood tests where we can look for cancer markers. Having a high blood test does not necessarily mean that you have cancer. It just means, hey, we should probably go take a look. Scans. MRI looks for tissue masses using magnetic resonance imaging. And if you have a cancer in any of the soft tissues inside your body, an MRI is probably the way it's going to be detected. Endoscopy runs a camera down your throat, into your stomach, or up your intestines, your colon, things like that. Basically runs a camera through you and looks for any abnormal growths in the lining of your digestive tract. Ultrasounds use sound waves to detect the density and shape of tissue. And they're usually cheap and non-invasive. And last, we have biopsy. Usually you're not going to do a biopsy until you know where the tumor is because you found it with endoscopy, an MRI, or an ultrasound. But when you do find a mass, you need to know whether it is just like a growth or a benign tumor or a cancer. And that means you're going to have to clip off a little bit of the tissue and look at it. And that's what a biopsy is. Non-specific warning signs of cancer. Don't freak out too much about these. Everyone has some of these. Changes in bowel or bladder habits. A sore that does not heal. Unusual bleeding or discharge. Thickening or lump in the breast or any other part of the body. Indigestion or difficulty swallowing. An obvious change in a wart or mole. A nagging cough or hoarseness. If you've got like one of these, then it's probably not something to worry about. Unless you get a change in a mole. If you get a change in a mole, get it looked at. And if you find a lump in your breast, get it looked at. But it's like usually when you have several of these together that you might have something going on. But cancers that occur inside the body are actually very, very difficult to detect. Because like if you get changes in bowel and bladder habits, that could mean cancer. Or that could mean bad Chinese food. And this is why when you go to like WebMD, no matter what symptoms you plug in, cancer is one of the first things that's going to pop up because so many different things have potential, like, are potential signs of cancer. It doesn't mean that you have cancer necessarily. Now, treatments for cancer. The first treatment, the best offense is a good defense. So, best treatment for cancer, don't get it in the first place. Prevention. Avoid environmental factors. Know the warning signs. Same thing like that. Treatment, or screening. So with most cancers, or like if you can catch them before they become malignant, they're very easy to get rid of. Most cancers. After they become malignant, they're very hard to get rid of. So early diagnosis is key with most cancers. Chemotherapies. Chemotherapy agents are chemicals that are basically poisons. But they're poisons that usually kill cells that are dividing. And the faster the cells are dividing, the more it kills them. So since cancer is a very rapidly dividing cell mass, these chemicals are going to kill cancers very efficiently. Most of your cells don't divide as fast as cancers, so they will be impacted, but less so. But you do have rapidly dividing cells in your body that are just naturally there. Your epithelial cells in your epidermis of your skin the hair follicles, the lining of your digestive tract, and the cells in your liver. And these are the places where chemotherapy has the most side effects. Your hair falls out. Usually your skin gets very thin and brittle. You have like horrible indigestion and nausea, and that's usually because the lining of your stomach and intestines gets very, very irritated because those cells are being killed by the chemotherapy agents. And liver toxicity, like that's actually what determines how much chemotherapy we can give someone. This is one reason why young, otherwise healthy people stand a much better chance of fighting off cancer than older people do. It's because they usually have healthy livers. And if your liver is pretty healthy, we can give you a higher dose of chemotherapy drugs without killing you. And our goal is usually to give you the highest dose we can without killing you, because that increases the likelihood that we actually get rid of all the cancer. Radiation therapy can be either targeted or non-targeted. It basically works the same way as chemotherapy. Since radiation induces mutations, and you're thinking, well, isn't that what got me in trouble here in the first place? But remember, most mutations don't do anything to cells, and those that do something to cells, most of them are just going to kill the cells. And remember what I said about the faster cells are dividing, the less time they have to fix mutations? Well, if you're a very rapidly dividing cell, like a tumor or a cancer, then the mutations from radiation are going to accumulate within you much faster because you're not taking as much time to fix them. And some of those mutations are going to be lethal, causing those cells to die. There is also like targeted radiation where we can like aim the radiation at particular parts of the body where the cancer is, because that's a lot better than just hitting the whole body with it. But basically, this is just another way of targeting rapidly dividing cells. And then we have surgery. So for some types of cancers, if they're localized or even if they're not, you want to get rid of all of the visible cell masses, right? The more of the big chunks of cancer that you can get rid of, the less likely it is to come back. And if it does come back, it's likely to take longer coming back. If you are diagnosed with cancer, chances are good you're going to get the trifecta. Surgery, chemotherapy, radiation. If what you have is a tumor, or what's called a precancerous lesion, that means that it's something that is quite likely to turn into cancer, but has not gone malignant yet, then you might get away with just surgery. Remove it. It hasn't gone malignant yet. As long as we get it all, it's gone. And usually they'll take the connecting lymph nodes as well, just in case. Even if there's no sign of it in the lymph nodes, you probably take the lymph nodes anyways, because you never really know. Chemotherapy is the next step up. That means that we are worried about it that means that we are worried about it spreading malignantly, and we want to hit it with the chemotherapy to get rid of any cells that are like on their own that are too small for us to detect. And radiation therapy is usually added on top of that, especially in severe cases. So if you have like a moderate case, you might get surgery and chemotherapy. If you have a more severe case of cancer, depending upon what type of cancer and where it is specifically, you might get surgery, chemotherapy, radiation altogether.